All right. All right, I think I'm here. All right, Captain Coder, it's me. I'm back after a full day break. We are back and working on refactoring this chess program. All right, so last time we went through and we took this chess program and we extracted, so it's all built into like one giant main method. Inside of that main method, let me shut this door real quick. Inside of that main method, we had a bunch of sorry, I guess I wasn't ready to stream just yet. Yeah, inside of that main method, we had a bunch of local functions. And so my goal here is to refactor this and to be more object oriented and try and make it so this is more testable and reliable, and we can have a better confidence in it working. So the person who wrote this code is on Reddit. They posted on the Learn Subsharp subreddit asking for some feedback and like asking how they can test their code, and a group of, a couple people online said, oh, you should look into unit testing. And I sort of went over their code, like, this is really cool. I've always wanted to make a chess game, a chess app. Never actually done it. So this is pretty cool. Let me check my audio. My audio settings look like they're doing okay. Here we go. That morning coffee is delicious. So we're just gonna take a look here, see if we can get some more refactorings done on this chess program. And then my plan is to take this video I'm recording now and chop it up into like a tutorial video, hopefully like under 20 to 30 minutes. Take the several hours and 20-30 minutes, chop it down to 20-30 minutes, and have a little video on like, oh, here's how we refactored this program. Maybe break it into a couple videos showing each of the steps. So all right, but yeah, we've pulled everything out to their single function. Now our goal is to identify code, or my goal is going to be to pull, I think I want to start pulling these chunks out into a class or an interface, a single class type, and then subclass it into logic and into moves. So they did a really good job in the sense that they were like, okay, I know I need a function that works just on each of the different pieces, those different moves, and so they pulled those out into it. So my plan in this, I want to refactor the whole thing, but the plan here is to try and work on getting pulled out into more classes, so that way we can start reducing some of the if statement stuff. So I'm going to start out here and I'm going to create a class, and I'm going to do an interface here, and I'm going to call it I piece for interface piece. And the idea is every piece in the game will use this interface, and we'll probably end up with an abstract class at some point, because I think there's going to be a lot of commonalities between the pieces. So here we go. Public interface eyepiece, and we probably want to be in the same namespace as our program. So our program has a namespace up here, console app. Which version? Let me see. Which version of C Sharp? We're using .NET 6. So we can actually .NET 6. We don't have to. I'm gonna change this namespace here. Oops. And I'm just call it namespace chess, like this. And then it's gonna want me to get rid of this down here, I believe. Is that gonna fix it? Or did I break everything? Format document. What is going on with these? The type or namespace print board could not be found. And then let's go over to well, maybe this was a mistake. Layout. Yeah, so I need to change this namespace as well. Namespace chess. So in C#10 and above, your namespace, if your file, usually I think it's considered good practice to have a single namespace per file. If you have a single namespace, you can now do a namespace at the top of the file. Let's see if that resolves that. Okay. So you can do a single namespace at the top. You don't have to do the curly braces, so your code doesn't get as indented. And so I always call that, if your program's going sideways, you know, so if your code starts getting crazy sideways, that means you're nesting a lot of if statements, a lot of loops. So it just makes it a little easier to read. Or you might argue it doesn't make it easier to read. I think it does. I do think it makes it a little easier to read. And then we've had this test that's like not super robust that we've been running, where we can, after every change, I spent an hour trying to make a better test, but for some reason I couldn't get it to work. So I have this test where we manually are checking that this game plays out to where there's a single king at the end in E5. All right, so I hope there's enough complexity in this game playthrough to give me a little, so this is giving me a little bit of confidence. It's already saved us once on a refactor. It's giving me, the goal is to have confidence that the changes you make have not broken the functionality. So my goal is to refactor this program to be a little bit more object-oriented, but without modifying the behavior of the program. Okay, so I have this eyepiece now, and so the goal, one of the things I want to do is, I sort of want to say, okay, well, eyepiece has what are the commonalities between these? And so there's a couple things that are important here. There's a moves and a logic method for every single piece. So I am going to do a moves method and a logic method. And for now, it's going to take in it's just going to be a duplicate copy of the code in here. But it's probably going to need to be a little bit different at the end of the day to know. So the board layout, I think, is a static thing here. So it's probably going to have to either have some state in it or take in some extra data. So because it's taking in a select in it. So let's see if we can understand what this code currently does. So moves prints to the board. It's going to update the board and show the X's where that piece can go. So let me run it. Let me add, if I make this delay, I've created a variable here that lets us change the delay more easily. So if I run this without the input, let's see what the not king moves, but what the moves methods are trying to do. So if I were to select P2, you're going to notice I'm going to select P2, lowercase p2, and X and an X are going to appear in these two spots. So moves is displaying the possible places we can move that piece. And so I'm going to create a method in eyepiece called public. And ideally you want, it does, let's see. It's a void method. So eventually we're going to want to change this from being a void method to a non-void method that returns something so we can test it. But for now, I'm going to keep it the same. This is going to return, maybe I'll do it. So I want to create a method that is actually going to give me back the positions in my board that it can see. So I'm actually going to go ahead and modify it. Rather than keep it the exact same, I'm going to have the method return the positions that piece can move. All right, so I'm going to make this method be, it's going to return, here's sort of a lazy-ish way we can do it. I want, each position has a row and a column. And so it's going to be an int comma int. Is that how we're doing it here? Array 0, array 1. Yeah, array 0, array 1. So they have an int array with the two indices. So I'll do that for now. All right, so it's going to be an int array of arrays. Is that right? Because there's going to be multiple pieces in there, so it can be int array. All right, I'm going to change the data type. I'm going to have it be an int, a pair of ints, row and column, an array of pairs of ints. So you're going to get a row and a column, and then you're going to get several of those. And so that's going to tell you how many pairs there are. And in fact, I want to use a list. I'm going to make it a list of pairs here. All right, so we're doing refactor, so it's whatever the code I want it to be. So I'm going to use a list here. And so this is I'm going to call this get possible. I'm just going to call it get moves. So this is going to return. So it's an interface, so I don't have to define the values. I just have to define what the method call looks like. And what do we need to be able to get the possible moves? This piece needs to know where it is on the board. It would be great if, well, this is interesting that there are no parameters. The auto generate was off a little bit. What would be really cool is if this piece just sort of knew where it was in the game state, and it could just tell us itself what its possible moves are. So I'm going to see if I can write the code in that way. Well, let's refactor it piece by piece. Let's refactor it piece by piece. We'll get there. We'll get there. So I'm going to start out, and I want to keep this signature. So we're going to say the selected index. I'm going to start saying, well, okay, well, you're going to give me the index, and I want to follow a little bit more C# guides here. So you'll notice I have this warning here. It's telling me, hey, well, that's actually just telling me it's not spelled. But now it knows that the word is select and index, and those two words are spelled correctly. My spell checker was telling me it was off. In C#, I think the standard for local variables is lowercase, and then lowercase on the first level, and then camel case for the rest of the words in it. So select index. And now let's create a subclass. I'm gonna create a folder here, folder, just to keep all my piece code together, piece. Move iPiece in there, and then I'm gonna create a piece here, and I'm gonna go ahead and do it with pawns first. I'm gonna create a subclass pawn, create new file, pawn piece. It might make sense not to call it pawn piece, but I'm gonna call it pawn piece, iPiece. Let's put this in the name space chess, and we'll put pawn piece in the name space chess, public class pawn. Let's make sure my program still compiles. And that my test sort of passed. I haven't changed any logic, so I mostly just want, oh, I need to change that delay back to 0 for my test to run a little faster. And this is an eyeball test. This is not a great test. But my program, this tells me my program compiles. So that means I haven't done anything like egregiously bad with my syntax or anything. My syntax is happy though. The computer, when you compile, the computer says, hey, I can do that thing. I don't know if it's the right thing to do, but I can do that thing. All right, so get move is gonna return the list of things. Let's do pawn piece. All right, so we're gonna start out doing, okay, pawn public, and all right, so we're gonna say that pawn implements iPiece. So it's going to be an iPiece. All right, and we're gonna implement the interface, and we're gonna get this stub here. And the idea I have for now, pawn moves, is we're just gonna take this whole method, we're refactoring, so we're gonna take this whole method, we're gonna put it in there. Just dump it in like this. And it's gonna yell at me saying I don't have a board layout. There's nothing called pawn logic. So we gotta get all of that. So then there's a move check, that print, there's a bunch of stuff we gotta do to make this happy. All right, so we're gonna have to make it happy. And so I'm actually not 100% sure how to make it happy yet, but I know I'm gonna need a board layout. So for now, I'm just gonna pass those things in, and I'm gonna try and clean it up as we go forward. But my goal is one step at a time, So we have board layout is a string array here. So I'm gonna make that an argument here. So this will be a parameter. And we're gonna simplify this as we go. So ideally, or you know what? Here. My pawn piece is gonna have that as a field private, read only. So we're gonna say that my pawn piece, I'm gonna need one of those, and I should match this pawn piece like this. I gotta pause just for a second. I'll be right back. Let me check my audio. All right. Okay, here we go. Okay, so I'm gonna make it so whenever I make a pawn piece, I'm gonna need one of these things. So we're gonna make that part of the constructor. So pawn piece, pawn piece has to take in a board layout. Ooh, what's interesting is the board layout changes. So this needs to be for now I'm gonna make this a ref. Can I do a ref? What do we do here? Ref is not available. In C# 10, please use language version C# 11. Okay, so this isn't gonna. All right, this isn't gonna work. No, I think this will be fine. We'll try it. Again, that's why we have our test to make sure it works. It's an array, so it should pass in a reference to that array to begin with. Okay. All right, so I got myself confused for a second. Public string array, double string array. So this is an array that has two dimensions, multi-dimensional array. And we're gonna do this dot board layout equals board layout. All right, so when you construct the pawn piece, you're gonna have to give it the board layout so that it has access to it down here. All right, index tile pawn logic. I'm actually gonna create another method in my interface for the logic. All right, so let's come over here. Pawn logic. Pawn logic. Here we go. We have select index and tile index, and it returns a bool. Okay, so we'll come over here. Public bool logic is what I'm going to call it for now. And in my pawn piece, we're going to just take that quick fix implement interface, and we're going to steal that logic from here. So the pawn logic method, let's see if we can get the whole thing here. It's down to there. Okay. So my pawn piece, I'm gonna take that, paste it in here. Okay, and then there's several other things that it doesn't like: move, checks, changes. So instead of pawn logic, this becomes this dot logic. All right. And so it's saying if the logic is, if we can make that move, this becomes an XX. Otherwise, change, equal to changes. Okay. Get moves. We're working through an index tile. We need to be able to call this method. All right, so I'm gonna do something that I consider gross for now, and then we're gonna keep massaging it to be better. So in my program, I've pulled it out. So index tile is an accessible index tile. Let's find where it's defined. Probably the first one there. So index tile is this method. All right, so for now, I'm gonna make this public. All right, so ideally this is gonna be like a non-static internal method that's on like a game controller object. For now, I'm gonna do this to finish my refactor, or to stepwise get through this part of the refactor. Okay, so here we are. Now my pawn piece, I should be able to do program dot index tile. Okay. Maybe I should have done that with these for now, but it feels gross. It feels like super gross to have those, but we actually, maybe we should for now, I'm not sure. Move check. Move check. All right, again, just for now. I promise this isn't gonna stay this way. We're just trying to get things organized. Yeah, just for now. We are going to be making these things public. Just for now. Let's, if we can we make them read only? That's not super helpful. Let's see if we can make them read only, so at least we cannot change them too much. They're lists and arrays and things, so that means we cannot change what the variable is assigned to, but we could change the contents of it. So we're just gonna have to not do that. Okay, get rid of this constructor for now. We're gonna do program dot on all of these, and ideally, what is select? Oh, select index is passed in this dot logic. It's interesting. It's changed to capital I index. Do program dot changes, and I'm this is getting a little bit wackier because everything's getting more global, but let's keep going here. Program, let's make this a const. Can I make const and delay? Yeah, I feel a little bit better if I'm able to do a const, public const. That is not, yeah, public const. If I give a const, I'm usually a little bit more okay with it. Okay. And then get moves needs to return this array, a list of these moves. So I'm gonna start at the top list of pairs of ints. Moves equals new, like that. And then at the end, so when we come in here, if we're able to make this move, moves.add a new pair with array 0, array 1. I'm not sure what this chunk of code is doing. So I know we're putting the X's onto the screen here. I think, move check. And otherwise, I think it's putting whatever happens to be on the board already. I'm not sure what the changes array is doing, but let's push forward. At the end of this, we want to return moves. Okay, so we're doing it. We're gonna actually print the moves. So it prints moves. It waits a second. It clears off, and then I think it prints, and then it like puts it back. Something like that. We'll have to look at what move. What is the type? Move check happens to be a print board. Changes happens to be a print board. So there's 2 print boards, and I think it's just a class that knows how to display the board on the screen in some fashion. Let's keep going with this refactor here. So let's keep putting this program in front. And I hope this refactor is gonna work. Follow the error messages. That's essentially a good strategy. Follow the error messages, run your test. Follow the error messages. There's a lot of logic here that could potentially, I don't know, maybe we could get this into some kind of loop here. Oops, I missed one. One's off by a little bit. Come on. Is that all of my errors? What do I got up here? Showing me some errors. I just missed some. Okay. So I haven't implemented this yet. So to start out, what I'm gonna do is in my pawn logic, for now, I'm gonna do pawn piece equals new pawn piece. So we're gonna create a pawn piece every time we go to call this. Instead of doing this chunk, we're gonna return piece dot logic select index comma tile index. So we're gonna slowly refactor this, and then same for pawn moves, like so. This is gonna be get moves of select index, just for now, just to see if I've correctly moved that chunk over without breaking. I see pawns and stuff moving, so I'm feeling pretty good. All right, so this gives me some confidence that that refactor was okay. All right, so I've pulled that out there. What I want to do is I actually want it so that the pieces in the game, there's like an eyepiece for every piece in the game. And I'll start by replacing those pieces with my pawn piece here. So ideally each pawn is on the board somewhere. And eventually I want the pawns to sort of know their own positions and stuff, so I don't have to be like passing these select indexes in. But I've got this pulled out here, and am I happy with that? So this is gonna get the moves. Let me add this comment here. Given, what is select index? Given a, oh, that's something I should refactor. I should make this pair. I should either write a class for a board position. Maybe that's what I should do. Write a class for a board position, or switch it to these pairs of row column. Given a position on the board, returns a list of possible moves that can be made by this eyepiece. It's going to return the list that can be made when we move, and then logic, given a starting position and a target position, returns true if the piece selected can perform such a move, and false otherwise. All right, so this is gonna be our start index, and this will be our target index, Call this start index. Get rid of that for now. That's sort of how, in my brain, I'm pretty sure this is like what makes more sense to me. And I want this to actually select index. I want this to be int row int call. Maybe I should do a pair. Int position. I'm gonna do that. I'm gonna make this int start position, int, and this just makes a little bit more sense to me. Target position. So our start position and our target position, and now we have to go. This broke. I'm sure this broke. If I were to not get an error message, but I'm sure if I were to try to run it, I'd get a compilation error. Yeah. Here we go. First off, I need to make this be int position. I'm gonna call this row column like this. So you can name your variables there. And there's gonna be errors in here. And then let me go ahead and do this here as well. So int row int call int row int call. And now I should be able to reduce this down to POS here for position. And array, what is array? Array, all right, so we can do this, int, it's a little bit harder here. So we're gonna do int row int call, target is equal to array of 0, array of 1. Okay, and then now I can do target here. And then for my add, this just becomes target. And for a little bit for me, I think reading it is a little bit easier to do target.row and target.call. Board layout target.row, target.call. Can I just put, I don't think I can do target here. No, dot row, target. I was thinking maybe there was some magic going on because we have a multi-dimensional array that maybe I could pass in a pair and it would just know what to do. Okay, so now I have start, position, and target. I'm gonna call it start and target. I should be able to go through and refactor this. So this should be start.row, start.call. And in my mind, this is a little bit easier for me to understand. So I need to replace select I with start.row, select J with start.call, tile I with target.row, and tile J with target.call. Okay, how do we do? Got a couple errors here. Get moves, given the tuple element's name in the signature must match the name of the interface. It's just telling me that I haven't. Okay, row. That's interesting. I didn't think it would require me to do that. That's fascinating to me that I have to name those. Or I'm not, yeah. Wow, that's really surprising to me. I didn't know that was the case. But in your interface, apparently you have to, if I name them here, I have to name them there as well. Which is a little surprising to me. All right, let's see if I broke anything. I'm sure, oh, yep, I have not actually, yeah, check it out. I'm not actually calling it yet with those. So, oops, select index of 0, select index of 1. Or actually what I'm gonna do, all right, what I'm gonna do is I'm gonna make it so this thing is taking in int start, slowly working my refactor through int target. And then I'm gonna do, once I figure out this pattern that I'm gonna use, I gotta go through and redo it. And even, you know, I'm gonna eliminate these methods eventually. So this becomes start, target, and same here. Start. And actually this one I like it better to be named POS for position. All right, and now I've got errors down here. Because the address, so now I need to make this be address 0,
comma address 1. And I'm just gonna do that for now. And then down here, again, address 0. Ref add. Ooh, this is 1. Pawn logic. Pawn logic's also in tile select, which is fascinating to me. Pawn moves. Address 1. And then the other error. Okay, so this one, it wants me to do 0, comma address 1 for the first ones. That's the first pair. And then ref add must also be a pair 0 ref add 1. All right. Ref add does not exist. Oh, I have 2 Fs. Ref add 1. Have any more compilation? There, it looks like we got. Let's try it. Okay, Phil gives me some confidence that I haven't broken the logic of this yet. I say yet. Hopefully I don't break it. I didn't break it with this change. Okay. So we are select.contains p or contains lowercase p. So this is like checking to see if the user started with the p, and then we're going to do the pawn logic. Then we do some stuff there. Our pawn piece, what would be really nice, let's see, this is in our tile select. In our tile select, be really, let me think here, be really nice. We want to, you know, the idea here is we have all these if statements here. It'd be really nice if for every piece on the board we could just do like a for that says check this thing, check this thing. So when the user does some inputs, it would be really nice to just say, okay, we'll get. So we do king moves and it shows those moves on the screen. So it's going through, it says check if it's whichever piece it is, do those, display those moves on the board, and then it waits for the user to pick a new spot. All right, so I've got my pawn moves here. So I know if I have something selected, so this in my tile select, what do these variables mean? I can't quite remember. So tile select, come down here. First we do a piece select, and did I write a comment for this? Okay. Prompts user to select a piece and it returns the selected piece and the row column of that piece. Ah, so it returns a row column with that piece. So I know that this is the label for the piece, and then this is where that piece happens to be. And then when we do select tile, this is where that piece happens to be. So now we're checking where that piece is. So what would be cool, what would be really cool, is if my tile select gave me back an eyepiece. Okay, so I kind of want static static eyepiece. So I want to get the piece that's at a location back. Tile select. So we're taking in, and I'm gonna, so I want to get, the other thing is I really dislike that we're using these ref things here, so I'm hoping I can eliminate those in my new tile select method. C# likes us to methods, at least public methods, I think. Methods you want to have with a capital letter to start out, that's sort of the standard. And then tile select. We're passing, and address changes though, right? So it ends up changing it to wherever that piece was selected. I think if we just do select like this, we should be able to get away with this. All right, because it's going to be what is the piece you're selecting, and I am going to do a little hacky thing to start out, which says that maybe we return an IP. So if we get null back, it means that we didn't get a piece, and we're going to fall back to this one. Okay, so let's see if I can do tile select here. So right now we only can select pawns. So my idea is if we have a P, and I'm gonna have to hack this out later, but if select that contains P or select that contains lowercase p. Can I do that in a better way? P, maybe. So we're gonna say if we're essentially trying to remove this option here. We want to create a pawn. Yeah, so we want to create a pawn. Return new pawn piece, like that. So we know we have a pawn, and if we make it to the end, we're going to return null. This is what I want here. And so I kind of want to, the idea is I want to get the piece. Okay, all right, so we're gonna try this. We have eyepiece selected. Yeah, okay. Piece selected, is that what we want? The idea is I don't want to have all of these if statements. The idea is if I'm able to find my piece, I can just call dot moves on it, and it'll do this thing here. So my goal is to eliminate all of these if statements and put them somewhere else. They're gonna kind of be here, but eventually my goal is to get rid of them, and the piece will just sort of know where it is. You start out by typing in a piece, and then ideally we'll loop through all of our pieces. Oh, that's what I need to do. I need to have a list. I need to have a list that has all my pieces on the board. All the pieces that exist on the board. And then those pieces know how to, they each have like a pawn piece in them. All right, so yeah, I think that's what I want. Okay, so I am going to use a dictionary, and this is getting a little gross. We have a lot of global things. I'm gonna start moving stuff into a class here. Let's see, have I broken anything? I can't remember if I've changed anything. Let's see if I've broken anything yet. I don't think I actually changed any logic. Okay, my test gives me a little confidence. All right, so I'm gonna create a new file. That's gonna be our game state. This is like tracking the state of the game. Okay. And I'm gonna slowly move different things into here. But the one thing I really want to be able to track, so we'll do namespace chess, public class game state. The thing I want to be able to track right now is I need a list of all of the pieces on the board. So I'm gonna make this one a private list of eyepiece pieces equals new I don't C#. I can just put that on the right side. And when I construct this, I'm gonna add all of my pieces into it. So public game state, And so I'm gonna go through and I'm gonna loop through and construct all my pieces. So I'm gonna start by constructing all my pawns. So I need, so I'm realizing I need some more things for my game, whether or not it's a green piece, whether or not it's a blue piece, what symbol it has. So I'm gonna start adding those here. So public string symbol. All right. So we're gonna create a property symbol, and so this is gonna tell us what it looks like when it's on the screen. And then I'm also gonna create public, I'm a little torn, I should probably make an enumerated type. So create a new file, piece color, public enum, and there's two, we got blue and we got green. So that way I can tell the difference between the pieces. All right, so we're gonna have a public piece color. Oh, I gotta put this in the namespace. Is that not how we do enums? No semicolon. Namespace chess. And again, I apologize that I'm not the best. Oh, I gotta give it a name. Piece color. Could have just used a string here, but this is gonna make sure that I restrict it to these two values, blue and green. Public enum piece color. So now I can do piece color here. Color. Get like that. Okay. So I have a symbol, I have a color. My pawn piece is gonna be real upset with me here because I need to add those in. So we're gonna create a public public string symbol, and the symbol, we have a get, and we're gonna have to add it to the constructor. So we have lowercase p, uppercase p, and then a number. So it's a little bit tricky to do that, but let's add a constructor here, public pawn piece. Okay, and it's gonna take in a string. Did I use capital or lowercase string for that? Lowercase string, good. Symbol. And we're gonna do this dot symbol. Oh, sorry, we don't have that. We need to have public string. We'll do two, private read only string symbol, and then private public string symbol get is just gonna be that there. This dot symbol equals symbol. Okay, and we also need to know what color it is, so we're gonna do the same thing here. So we're gonna have piece color, and then private read only piece color, public piece color get goes to color. This dot color equals color. What did I miss? Semicolon. What am I missing here? Is this a fake error? A real error? What is, oh, I didn't give it a name. This should be color. No semicolon at the end of that. Okay, so now my piece is aware of its color and its symbol, and my interface contains that information. Okay, so I think it's good practice, I can't remember, to put all of our like private variables in public. I kind of like grouping them like this. They're like, well, this thing is backed by that. Someone should let me know if that is like a bad practice. This is something I like to, again, I'm not a C# expert by any means. I like to, if I have a getter that's backed by a private variable, I like to put them together. Is that a crazy thing to do? Let me know. I don't know. When I've looked in style guides, it sort of says all your private things should be like separate from your public things. but I don't, this seems like a good, keeping them together feels good to me, but maybe that is bad. We should probably put a comment on these, but I'm gonna keep pressing forward because ideally I'd put a comment here, and then that sort of gets propagated down to all of them. So the 2-character string representing this eyepiece on the board. The color of this eyepiece. Okay, and I know these comments seem stupid, but if it gives it, so like now if I hover over symbols somewhere in my code, it's gonna give me a little bit of information. And then I believe I'm not 100% sure, I think I might have to put inherit on it, but if I don't, let's come find where I've created my pawn piece. I'm curious if I hover over logic. Yeah, so if I hover over logic, I get that comment still. So you put it on the interface, now it propagates through. So in my pawn piece, I have those symbols. All right, in my game state, I was gonna construct all of the pawns. Okay, so I have 8 pawns on each team. Each player gets 8 pawns. So for int I equals, and they start with 1. I is less than or equal to 8. I plus plus. We go through and we're gonna generate those pawn pieces. So I piece pawn equals, and we got to generate one for each side. So this will be blue pawn equals new pawn piece, and the symbol is going to be p lowercase p plus I, and it's going to be blue. I piece green pawn, it's new pawn piece, capital P for the green pieces, plus I piece color dot green. Then we're gonna add these to our list. Pieces dot add blue pawn, pieces dot add green pawn. And you might argue that, well, if I'm just gonna add it immediately, I might as well do this. I don't need an intermediate variable. And in this situation, I think I agree with that. All right, so this is gonna build up all of our pawn pieces that are in our game. The one thing that would be kind of nice and is if these pieces knew their position on the board. So I'm gonna add, in my I piece, I'm gonna add that pieces. I want my pieces to know where they are on the board. And so this is gonna get a little tricky. Because we have to now track some state. These are no longer sort of like just immutable logical pieces. But the cool thing is if it knows its position on the board, I no longer have to pass this variable in here or here. It simplifies my get moves method call and my logic method call. So it should be able to just know where it is. So I'm gonna create, I'm gonna make it so I can have an int position. This is gonna be a get, just gonna do a get and return it. There's no set on this. Instead, I'm gonna end up writing some kind of method, I think, to like, maybe I should do a set, probably not. Seems dangerous. Well, we might need to be able to set it. Yeah, we'll see. We'll see what we have to do here. I'm gonna do this for now. Setters are, I think, if possible. So there's like this principle of keeping things as immutable as possible. If you can keep something immutable, then you don't have that class of bug. You can't accidentally have an error with changing a reference. So I'm just gonna add this in here as a position. And our pawn piece is now gonna need it. I'm gonna implement the position. And just as I did with this private, this one needs to be able to change. All right, so this one needs to be able to change. Maybe I should make the position have a setter. I'm not sure. Oh yeah, I forgot about that syntax. So fun little syntax with this. If you only have a getter, I think you can do it like this. Since I'm not allowing setting, we can just do a forward arrow like this. All right, so we're gonna do private int position. Lower underscore position. Private variables tend to be this way. This one's not read only because we need to be able to change the position. And in my constructor, I'm going to tell, well, you got to tell me the starting position. So int position. We'll do this dot position equals position, and then my get for now. And it may be the case. So I might make this have a setter and then do some conditional checks. Say, okay, well, we can only set it well inside of the bounds of our array. Let's add a comment to our eyepiece real quick. The position of this eyepiece on the board. All right, so the piece is aware of its location. So we don't have to, that's sort of what we're hoping here. All right, so in my game state, now when I construct these, I can do it. So I know all of my blue pieces, if I go and I look at a board, all of my blue pieces start in row 2. So that would be index 1, I believe, based on how it's doing it. Let's look at our program, I think. Yeah. So index 1 would mean row 2. All right, so index 1. So these are all gonna be in 1, and then I'm gonna go with I for my column because it just puts them across, starting with 1. All right, and did I get on my, I think it compiles. I haven't actually made it use these yet. Oh, and of course all of these are broken now because I don't have an actual pawn piece. So let's fill it in with some temporary values. P, just to make sure. Piece. So right now these aren't being used for anything, so I can put basically anything here, some temp values. I just want to make sure my goal, but what I'm doing here is I just need to run my program to make sure that my pieces go 1 through 8 on the top and 1 through 8 on the bottom, and that they don't, I can't, I just want to do a .NET around here. Yeah, 1 through 8, 1 through 8. And I'm realizing in my game state here, it seems to be I minus 1 because we're indexing 0. We indexed at 0 on this. And instead of 1 here, this should actually be row 6. That's the second from the last row. All right, so that's sort of my plan here. So I have this game state object. Done a lot of coding here without actually putting anything in here, but my goal here is, all right, let's see if I can get my pawns to work. So my program, in my program, I now have my pawns. Okay, so let us create a game state that we can have here. So private read only static, because our main method's static, game state equals new, and we'll call this game state equals new game state. So this should construct and have our pawns in it. Okay, and we want to have a method that's going to let us get our pieces out of this. So I want to select a piece, right? So I need to be able to get a piece out of this game state. So I'm gonna, yeah, here's what I'm gonna do. So I want to be public eyepiece question mark. It's gonna give us an eyepiece. Sometimes it gives us null back if it doesn't exist. Oh, I'll just do eyepiece actually. Eyepiece get Here's how I'm gonna do it. No, I'll do a maybe eyepiece that's nullable. Get piece, and it's gonna take in the symbol, and then it's gonna return that piece if it exists and null otherwise. So I'm gonna use a dictionary, public, private, sorry, read only dictionary from string to eyepiece. If you're not familiar with what a dictionary is, it's essentially an array that you can index by something other than an int. In this case, we're indexing by string. So we're gonna be indexing by the symbol of the piece. Okay, so we have this dictionary, and this is gonna be called, so we have a list of pieces to, I don't even know if I need this list anymore. So I was just thinking I needed a list. I actually think I don't think I need a list here. And so I'm gonna call this pieces. And instead of add, I'm putting p plus I is equal to this thing here. P plus I is equal, capital P is equal to this thing here. Okay, so this is gonna go through, create all of my pieces, and let us find that piece directly in our index, into our dictionary. And now here, I can use my pieces dot get, is there a get value or default? Okay, so I can say get my symbol or null, and we're gonna return pieces is not null here. What do you mean pieces is not null here? Not be used for parameter dictionary. Get value. Tries to get the value. I'm a little confused. Oh, it's saying that. Hang on, I'm a little confused here. Pieces. You cannot be null here. Container cannot be used for parameter dictionary of type. Get value or default. Tries to get the value associated with the key. Returns eyepiece instance when the method is successful. When the method fails, it returns default value. I think it's telling me that this type needs to be a question mark, which I don't like. Because I want this dictionary to only contain those. All right, so I don't know what's going on here. So what I'm gonna do, here's what I'm gonna do instead. I'm gonna say if pieces dot contains key symbol. Well, I can even do better than that, symbol. Return pieces of symbol. Otherwise return null. So this like hides, so here's the cool thing. This is gonna help us eliminate all of our ifs by sort of storing them inside of here. So this code contains keys sort of has all of those ifs that we had written, that are written here. If we have all of our pieces in here, the cool thing is, where is that tile select? All of these if statements are checking for the right symbol. These are now going to be like stored in our dictionary. We're just going to get it out from our dictionary and be happy. Let's keep moving forward here though. I don't like that I have to sort of index in here twice, so I think there's a try get value, yeah, symbol, then we can do out eyepiece value. No literal or possible value to non-noble. So in this case, do I need to do that? Okay. Okay. So what this does is if this successfully gets something out of the dictionary, value gets set to it, and so we return value. Otherwise, we're going to return null down here. So if this is false, it means that symbol did not exist in our dictionary. All right. So here's how we're going to do this now. Here is how we're going to do this now. We are going to say eyepiece question mark piece equals game state dot get piece select. We're gonna take that, we're gonna pass it in there, we're gonna get the piece out. Okay, that's a fake error. That's a lie. VS Code's lying to us. We're gonna say if piece is null, we're gonna do all of these things. So if the piece is null, we're gonna do all of those things. Else, all right, so if the piece is null, that means we didn't find it. Else, we know piece is not null. So in this else block, we know it's not null, so we can actually do piece dot get moves with our row and column here. With our row and column. Okay, all right. That was a lot of refactoring. That was a ton of refactoring to get here. But we're gonna test it out here with our, did not mean to click that, I'm gonna click this one. Let's, that's interesting. Must have closed my terminal. That's all right. .NET run. Will our pawn piece P1? Oh, I gotta set my delay back down so I can actually, so it'll pause for a second. Delay to a second, so we have so it'll pause for a moment. Select tiles. Select tile? What? My brain cannot remember what this tile select. That's what it was. So I would have called it select tile. That's just my preference. Tile select is totally fine. And if I were to, so ideally, I should be able to get rid of that and have the same outputs. P1, yes. Back. P2. All right, let's move P2. P2 to B4. Capital P2. Check it out. All right, so I've removed, I'm pretty happy with this. I've removed that if statement. So now, if I were to write a piece that has a moves for each one of these, then I'm gonna slowly be able to like remove each one of these and continue to have that logic built in without all of these if statements. I believe this is called dynamic dispatch. So this method get piece is going to select the piece we want for us, and then rather than having to have to explicitly say which method we want to use, inheritance is going to select the method for us. So we have get moves here. All right, so get moves is going to dynamically select that for us. So we get moves, it's going to come into the pawn piece. So whichever one happened to be in the dictionary in that spot, it's going to be like, okay, here it is. Boom, here you go. I know how to display this thing. All right, beautiful, beautiful in that regard. So I'm no longer calling, am I calling pawn moves anywhere else? Pawn moves. No, pawn moves is nowhere else in this code. So I can delete it. I can delete it. I can get rid of it. All right, so now let's look at getting rid of pawn logic. All right, pawn logic. Pawn logic is only in this one spot. So can we get rid of this? All right, so I think this will be relatively easy to do. Because we can write a check up here. So if tile is back, all right, then we're gonna go to P select, do some stuff. Eventually we want to get rid of all of this stuff too. Please input a correct tile. We have a bunch of if statements here. Bunch of else. Please input correct tile address. All right. So we have like this giant while loop here. I'm trying not to break anything. Well, let me, before I move forward, I wish my input output test was I could get that to work. Let me shut my delay back down to low. I wish I had gotten my input output test to work properly, because it would be nice to be able to have confidence that I haven't accidentally deleted that and still be able to run all of this. All right, so the logic of actually moving hasn't been chopped off yet, or modified. Let's keep going. Okay, where do we got? What do we got here? It's way down here. Tile select. All right, so I would like this to be this way. Format. So I'm gonna say else if piece is not equal to null. So if my piece isn't null, I want to use so ideally this chunk of code sort of goes away, because I'll never be able to select the P on its own. But rather than using pawn logic, so if piece is not null, I'm gonna say if piece dot logic. That's going to take in the row column. So address 0, address 1, comma, and then ref add 0, ref add 1. All right, if that's the case, if it's not, all right, so we say if we cannot do that, else tile. Because the tile was selected up here, and that's the new tile. Okay. Else return tile. Okay. So if the logic of the piece doesn't work, we're gonna get invalid move. Why can't I return? Okay. Invalid move and do it. So the cool thing here is I should be able to take out this pawn, because I've created all of the pawns in my game state. Let's try it. We'll run this test and I'll do a little bit more testing. It does still work here like this, but this I think only has valid moves in it. So our test would have been a little bit better if we put invalid moves in there as well. All right, so let's try P1. And let's see if we can move to A8. We can't, but I can move to A4. Okay, so that seems to still be working. I'm pretty happy with that. So we have a basic framework here that says if I can get all of my pieces into my game state, I should be able to eliminate all of this code here. All of this whole giant chunk of code here. So I'm pretty excited. I had to logic my way through a lot of this and muscle through it, but I think we're here. All right, so I'm gonna do a commit before I move forward. Git status, git add piece, git status, git add add it all, git status, git commit dash m. I'm gonna do a work in progress, WIP, work in progress. Add eyepiece and game state to reduce complexity. Alright, and then an additional comment here. Implemented pawn piece and refactored program.cs to, oh, I haven't quite done it yet. Let's cancel this commit. I want to get rid of pawn logic. Yeah, so pawn logic is no longer used anywhere in this code. There we go. So now I can do this commit. Git status, git add program. So my goal was to remove pawn logic and pawn moves. All right, so now it's deferred into the pawn piece class, and so I can do this commit here, which was implemented pawn piece, implemented first attempt at pawn piece, and removed pawn moves and pawn logic from the program CS file. Okay. All right. So I have my pawn supposedly working. My tests are not super robust, but I have this basic test that when I run it, I see that, well, the game still plays out to the end, so I have some amount of confidence that it's still working. Okay, let us continue. So now I need to do it for each of the other pieces. So let us start with, I have king. King's the one at the top here, so create new file, king piece. Okay, now we're gonna start seeing some interesting things. I'm gonna start seeing, well, I have a lot of code that is the same between my king piece and my pawn piece. Can I find a way to abstract that into a single location and not reuse? So dry is like what they call it. Don't repeat yourself. Anytime you can remove repeated code, do it. Okay, so namespace chess, public class, king piece, implements IP. So we're gonna start out doing it the gnarly way. Gnarly's not the right way, but the like straightforward way. All right, so we're gonna start out doing it the straightforward way, which is to just copy everything over. And as I go here, we're gonna add our constructor. All right, so check it out. You'll notice the position and stuff just is here, but we haven't, you almost certainly were like, well, this code is not working well yet. The piece is moving, but it doesn't update this thing here. I know, we'll get there. One thing at a time with the refactor. All right, so this code here was essentially, let me close others for now and get my symbol color position from my pawn piece. All right, so my symbol color position from my pawn piece, you might be tempted to do this. Let's copy it over and say, okay, well, these are all, and then my constructor. You might be tempted to do this. And then change this to king piece, copy and paste. But we just said, okay, don't repeat yourself dry. Don't repeat yourself. That's what DRY stands for. So what we're gonna do is we're gonna create a common parent class between the two of these things. So we're gonna create what's called an abstract class, because each one's move and logic is going to be different, but essentially this is all gonna be the same. So new file, abstract piece. All right, so we're gonna create an abstract class, namespace chess, public abstract class, king piece, implements IP. So the thing about abstract interface. Interesting. Chess already contains a definition for king piece. What do you? Oh, duh. This should be abstract piece. My brain, I couldn't figure it out. All right, so this is abstract piece, and then it's saying implement it here. So the cool thing about abstract, all right, so the main, if you're not familiar with abstract, so we talked about interface. Interface lets us define methods but no implementation, so we can sort of be like, all right, these, I promise these things are going to exist. And then we get polymorphism. So in our program, or if we go to our game state here, notice we have a dictionary from strings to I pieces, not strings to pawn pieces, so we can keep them separated. So I can actually put anything that's an I piece into this list, doesn't have to be a pawn piece. And then when I call a method, it's gonna defer that to the correct subclass. But with interfaces, I cannot provide implementation, or you typically don't provide implementation. I think you can have like a default implementation in the most recent versions of C#. But we're not going to do that. We're going to do that in an abstract piece class. So abstract, you'll notice I don't actually have to implement all of these things, or I shouldn't. I implement abstractly. So I can say, oh, this thing is a method that's going to be abstract. It says, I'm not going to implement that. My subclass is going to, so whoever extends this thing is going to implement it. But we're going to have a default thing here. So these ones are the commonalities. So in our abstract class, we have the commonalities. So this is going to be our abstract piece here. So every piece is going to have a symbol, color, position. And then I'm going to take these, put them in here. Symbol, color, position. Our abstract piece has that. And we're going to defer. We're going to say that, well, every piece moves a little bit differently and has a little bit different logic. So we're going to make that so our subclass has to implement that. So instead of doing I piece here now, I'm going to say that this happens to be an abstract piece. I can get rid of these here, and instead I'm going to pass this off to my constructor. I think the way I do this is I do base, symbol, color, position. And I think I still need these. So, and someone tell me if I'm wrong here. I think I still need these parentheses, but my constructor is now not doing anything. All right, my constructor does nothing in this case. I'm probably gonna end up writing some stuff that ensures that if I'm a king piece, I have to be a lowercase k or a capital K, something along those lines, or will automatically generate it for us. And like check that the position is correct. I don't know for sure yet how far I'm gonna take this refactoring. But we tell it, hey, use the base class, which happens to be our abstract class, and use its constructor when we construct this. So if you're extending a class that does not have a default constructor, so in this case, a default constructor is one with no parameters. In this case, we have 3 parameters. We need to know how this thing is, what the parameters are, how we're going to construct this. So we tell it, we'll use the base class, which is the parent class. And we're just going to hand off symbol, color, and position for now. And then I believe, let's see what this is saying. Implement abstract class. Yeah, so when you implement a class, when you extend a class, you have to use override. All right, so it's complaining that I haven't done it yet. So in all of these, we have to explicitly tell it that we're planning to override the classes, the parent classes method. And this is how the dynamic dispatch works. This is how we get it to say, okay, defer when I see get moves on something that is an abstract piece. Don't use the one in abstract piece, instead use the one in the subclass. All right, so not implemented here yet. Let's get this working for our pawn piece first, and I'm gonna come back to my king piece. So my pawn piece is going to now extend abstract piece, and all of this code goes away because it's in my super class. It's in the abstract piece. My pawn piece stills that. I replaced the constructor name there. I did a little copy and paste. Override. Like so. So the only thing that's different is my get moves and my logic. Get moves and logic. Okay. Let us run the little test I have here to make sure my program still seems to be doing what I want it to do. Pretty happy with it so far. Still is looking like it's working. Let's see if we can get the king piece logic and moves methods out of the program.cs. All right, so let's go to our program. We're gonna pull those out and drop them in here. Where is program? Program.cs, we'll open that up. King moves. I'm also noticing, hey, check it out, we got this commonality here, but it'll be a little bit easier for us to see those commonalities once we get this into our king piece here. All right, and we've been doing program dots here. So no, again, I keep repeating myself on this, but I'm trying to refactor one chunk at a time. One chunk at a time. This dot logic. One piece at a time, and slowly. I actually think get moves might be a little thing that we don't have in abstract piece. I'm looking at it, it looks almost identical. I think we can keep this all in abstract class, but we're gonna find out here in a moment. We gotta get all this working first. Program dot, selected indexes around moves, changes, move, changes, program dot delay, select index. This actually becomes what this is, position dot row. It's actually just position because logic takes in these tuples, pairs. And then this, I'm gonna do a pawn piece. I can actually, yeah, I'm noticing that this code is essentially identical to what's going on in my pawn piece, right? So, because I see that it's identical to my pawn piece, I can actually, this doesn't have to get overridden by my subclass. Let's see if I can do this. I'd be really happy if I could get away with this. My pawn piece. Let's move this into my abstract piece class, and then I don't have to repeat myself. Abstract piece, like this. Doesn't need to be override anymore. All right, I think because this is using this dot logic, it should, the only thing we actually need to do is the logic for each piece is different. The way we get moves is by using the logic method. All right, so this is kind of cool. That's kind of cool. Let's make sure. I'm gonna set my delay. Program.cs. King moves. Yeah, my goal is to get rid of king moves. All right, so I almost got king moves out. Right now, this is actually, see, I would have gotten caught here if I had my input output test working properly, because it would have told, hey, your king no longer displays the X's around it. But let's check this out. P1 still displays my X's properly. Okay, I'm feeling okay about that. Where is my king piece? The king piece logic now. I need to get that in there. So let's go to my program, king logic. Pull this out into here. So this is a little bit tricky. I'm gonna get rid of these. And like we did before, so I'm 90% sure if we put these side by side, it's quite different. Quite different. King logic, it would have to be. I'd be amazed if they weren't like drastically different. The start of these two seem to be the same, so maybe there's some commonality I can get there. But then down here, the king logic basically checks all of the king logic. Is interesting. King should be able to move in any direction. Oh, that's what they're doing here. Okay, so this logic is basically saying that the difference in I and J is at most 1. I'm pretty sure is what it's saying here. If it's not 1, then we return false. Okay, let us come back here. I need to, the way we did this before. All right, so we got to put program in front of each one of these. So we got changes dot becomes program dot changes dot. All right, select I becomes start pause dot row. Select J becomes start pause dot column. Tile I becomes target dot row, and tile J becomes target dot column. So we'll get all those replaced in here. Target pause. So I'm just gonna name this target. Okay. And then if I really want to be target pause, I could. I'm gonna rename this to just start as well. So I think I have my king logic here, and let us get rid of these to find out where excuse me, where we need to chop them off. So king moves. Ideally we get rid of this, and we're going to chop this chunk out, and we're going to chop out this. Okay, we get those two things cut out. Our program is definitely going to be broken right now. If I try and run this, my king no longer let me change my delay to 0. My king no longer can actually be selected because I've removed that option. Completely removed the king selection. So I need to add it to my game state next. So as soon as my king just never moves, I'm gonna get crash. Does not work. Okay. So in my game state, I need to add K1 and K2 to my dictionary. All right, so pieces K1 is equal to a new king piece K1. So let's do the blue one. So that's lowercase. And my king starts in what position? Let's look at what we have on our board here just without running this here. All right. So my king should be in position 0, 0, 1, 2, 3. 0, 3. 0, 3. Pieces capital K, not K2, is new king piece, capital K. Piece color dot green, and it should be 7, 4, I think. 0, 1, 2, 3, 4. 0, 4. All right, if I do this, this is all I had to add here. I took out those two if statements. If my logic was correct previously in my program, Now I've got rid of those. Let's see where I have eyepiece. My get piece, so we're gonna say if my get piece, so I've removed the king thing, it says piece.get moves. It's going to defer when it selects K1 or capital K, lowercase K1 or capital K1, it's going to defer to the get moves in the subclass. Oh, and it's in fact the get moves in the abstract class, which should hopefully be the same between the two, but that uses logic, and so it's going to use the logic from my subclass. So more importantly, right here, if my piece is not null, I use the logic in my subclass for either pawn or king. Fingers crossed. I'm feeling relatively confident. Let's run this. I just saw the king move. All right, we've made some real progress here. I'm happy. I'm going to commit that I've implemented my king piece. So get add everything, get status, make sure to add anything weird. Get commit dash m. This is my work in progress. Add abstract piece and king piece. And I'm gonna add a little bit more here. It says created abstract piece and moved commonalities of pieces into abstract piece. Created king piece and moved logic from program.cs2 subclass. Okay, so I've got my king piece logic in there. Let's keep going. It's not going to be long now before we got before this if statement's just completely gone. That's the ultimate goal. This will be completely gone, and then I'm going to change my get piece. Rather than returning a maybe thing, it'll throw an exception if that piece is not valid. All right. Oh, and let's make sure my king still shows the correct X's around it. I feel pretty good that it will, based that logic seems to be working, and that the get moves uses that. But let's try it real quick. Delay. I need to make my delay a little longer, so that way we can see it here. Okay, so let's move P4 to D4. P5 to E5, K1, I get my X out, K1 to D2, capital K1 to E7, let's move K1, all right, it looks, I'm feeling happy about this, to D3, capital K1 to D or F6, K1 again. All right, I feel pretty confident with that it's displaying the correct positions. Okay. All right, let's continue. What's the next piece we got to pull out? We've got knight logic. All right, so I'm going to create another class here. New file, knight piece, and this is going to be, as we've engineered this a little bit easier and easier, the refactors become smaller and smaller. So we started with like a big refactor, pulling everything out so we can start extracting things. But now we got namespace, chess, public class, knight piece extends abstract piece. And then we can sort of, I'm gonna just copy these two lines, change this to knight piece, like so. And then we're gonna move the logic from our knight piece, close others, get my program, .cs open. The knight logic is the thing that we have to pull out and refactor. Knight logic. Ah, I see. Okay. Pull this knight logic out here. My brain was thinking through it for a second. All right, and we decided that we can do changes dot. It's gonna be program dot changes dot select I becomes start dot column row start dot row. Select J becomes start dot column. Tile I becomes target dot row. And tile J becomes target dot column. And then we'll do a format on this. And then in our program, let's move knight logic, knight moves. Oh, this is just feeling very, very nice to me. And then this is going to inform us where we want to delete this if. And this whole knight chunk here. And then in our game state, we're gonna add our knights. We're gonna add our knights to the board. So we have N1 and 2 pieces. And let's get our initial board here just so we can see, so my brain can handle it. N1, new knight piece. N1 is the blue piece. And it starts at row 0, column 1. Okay. And we'll go with capital N1 next. And all that changes, this becomes 7. And then we'll get N2s. Okay. And our N2 is in column 6. Okay. Okay. Column 6 here. Let's run our input test here. Oh, it's changed my delay again. I should really make that an input parameter. It'd be much easier. All right, gives me some confidence that it's working. Let's see. .NET run. Let's check if I do N1. Yeah, it tells me which spaces I can still go to. We'll go ahead and go to C3. Try N2. Let's go to F6. N1. Yeah, I feel really good about that. Okay, so that refactor for the knight became really simple because we have the only thing that's different about the knight is the logic. So now we've removed a ton of code. So git status, git add everything, or git commit -m work in progress, add knight piece. I'll put removed or put knight logic in knight piece and removed associated methods from program.cs. All right, let's keep going. There's only a couple pieces left. Bishop moves, just. Oh, did I remove knight moves? I bet I didn't have knight moves. Oh, I did. Okay. Bishop moves goes away. Bishop logic is going to be put into a new subclass. Bishop piece. Okay. Namespace chess public class bishop piece extends abstract piece. Follow our pattern here. Take just these definition lines and make it bishop. Close this off and move our logic in there. Here's our logic, like so. Get rid of this, and we had get rid of that chunk there. We're gonna do changes dot is replaced with program dot changes dot. We do select I is replaced with start dot row. Select J is replaced with start dot call. Tile I is target dot row. And tile J becomes target dot call. Okay, and we'll go ahead and do a format. Much nicer, much nicer. I like it. Yeah, I'm feeling pretty good about this so far. Bishop, this is nice. Bishop sort of checks the diagonal. Okay, continuing forward, we have to update this to remove this if and this else if. Oh, I'm feeling happy, feeling very happy here. Let's then do, in our game state, we have to add our bishop. So let's get those positions just on the screen so it's a little bit easier. All right, pieces, B1 is gonna be new bishop piece, B1, piece blue, 0,2. Oh, one little mistake I made previously, which has not flared its head, but I just saw, because I didn't change the piece color to green. That would have been an issue when we go to refactor like the display system. The display, oh, I'm so excited. The display system, we're gonna get rid of nested loops. It's gonna be beautiful. But stay tuned. Gotta stay tuned for that chunk. All right, so B1, this one's in row 7. And then we've got our these 2s. And B2, this is gonna be in column, what is that, 5? 7, 6, 5, yeah, column 5. Let's make sure our bishop still gives us correct output. So let's go P4 to D4, P2 to B5. All right, and then let's try B1. Boom, there we go. We'll move B1 to D2, and we'll capital B1 to B7. We'll try B1 again. All right, I'm feeling pretty good. That refactor wasn't too bad. And of course we should just really quick make sure our input test still gets us down to a single king in like E5, I think. All right, and then get status, get add, get commit -m, work in progress, add bishop piece, refactor bishop logic to be encapsulated in bishop piece. All right, let's keep going. We're almost done with pulling out all of our logic. Rook moves, so we'll do the rook next. Create new file, rookpiece.cs, namespace chess, public class rook piece, extends our abstract piece, Let's still this here. And then we'll move our logic and do that refactor. So we're getting into like a you know, what I would call a flow state a little bit. Rook moves goes away. Rook logic, I don't need that first chunk. Rook logic, delete that. Chunk it in here. Do our replaces. Changes dot comes program dot changes dot select I becomes start dot row. Select J becomes start dot call. Target, sorry, not target I. Tile I becomes target dot row. Tile J becomes target dot call. And we've got it. Something weird happened up there, but that's okay. I'm not sure. Format document, and then I'm gonna come in here, get rid of my rooks. Oh, this is starting to look so nice to me. So nice. Look at how much the simplicity. We've managed that complexity by shifting things a little bit. Let's test out our rook. .NET run. P1 to A4. P1 to A5. R1. Oh, I didn't see. All right. My eyes aren't fast enough. Let's do this. P1 to A4. P1 to A5, R1. Oh my. R1 should be able to A3. Something has gone wrong. Okay, all right. I've done some, oh, I know what I've done wrong. Yelling at me, I haven't updated my game set. I didn't tell it that there were rooks on the board. Let us do that. Let us go through and do that. So R1, capital R1, R2, capital R2, 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 and this should be rook piece. Okay, blue, green. And my rook starts 0, 0, 7, 0, and then 7, sorry, 0, 7, 7, 7. Okay. Now let us try this. P1 to A4, capital P1 to A5. R1, there we go, to A3, R1 to A6, R1, there we go, feeling good about it, feeling good. Get status, get add, get commit, work in progress, add rook piece, refactor rook logic to be encapsulated by rook piece. And I think all that's left is the queen logic. Is that true? Queen moves. We can kill that method. And then we have queen logic. Queen logic, so let's make a new file. Queen piece.cs. Namespace chess. And then rook piece. Sorry, not rook piece. I don't know why I'm copying that yet. Public class queen piece extends our abstract piece. And I'm gonna start with just these. make this my queen piece constructor, and then the logic we can still from here. It's the longest logic one, I think. And do our format, and changes dot gets replaced with program dot changes dot. All right, select I becomes start dot row. Select J becomes start dot call. Tile I becomes target dot row. Tile J becomes target dot call. Format. We need to fix this. Look how beautiful this is. We've gotten rid of this here. All of those if statements gone. All of those if statements gone. All of those else statements gone. All of that complexity removed. All of the complexity removed from these methods, and sort of using the dictionary data structure to defer and do our ifs checks for us in a way that makes our code much less complicated. You have to understand how dictionary works to make it happy, to be happy with this. But the code size is really much smaller, and smaller code tends to be less complex. Let's add our queens here. All right, queen Q1, 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 capital Q1. And you'd think my brain could do this without doing this section, but I can't. I probably could. I could logic my way through it, but 0, 1, 2, 3, 4. So this should be 4. So I should have just said, oh, well, it goes next to the key. 3, 0, 1, 2, 3. Okay. So we got my king and queens added. Let us test that the queen has the right move set attached to it. So I'm going to move out P4 to D4, P5 to E5, Q1. Something's gone wrong. Queen should be able to move more than that, right? So I should be able to move down this entire diagonal. Was that the case previously? What has... Something did not go right here with this refactor. Something did not go right with that, with this chunk. Let's run the bigger one just to make sure I'm not crazy. But this is probably gonna, oh, I gotta get that delay down. Yeah, the queen is broken. We've broken the queen. So let's reverse and see what's happening here. The queen logic is trickier than we had anticipated. So I've put the queen moves, queen logic back in. To make sure it was working before. All right, let's get my logic delay back to 0. I'm 90% sure I test this. I'm real sad if I have to go back and I have a bad commit. Oh no. Oh no. Get status. Okay, so get reset hard. All right, we're just gonna go back to the most recent commit when I added the rook. Did I break it? All right, hang on. I just sort of, did I not run this full test here? Okay, so when I committed it before with my rook, I was fine. Something went wrong. Oh, I know what went wrong. I didn't change king piece to queen piece. So the queens, even though they had that symbol, were using the king logic. All right, so can I get all of that back? Queen piece looks good still. All right, so, all right, queen move, game state, oh no, I did change it. Oh no, I didn't change this. Queen piece. All right, someone was probably yelling at me in that regard, but we got it now. Let us get rid of this again. Can I just do an undo here till it gets back to, all right, before I really mess stuff up, let's go queen moves. We're just gonna get rid of queen moves, queen logic. Okay, like that. And then in our spot here, we get rid of this. And we get rid of this else if, like that. And check here. All right. P4, D4, P5, E5, Q1. Oh. Q1. Am I just going too fast and I couldn't see it? I think I would have saw A5. Oh, I think I just have the delays too high. I'm missing it. Wish my output test was working so I didn't have to manually test these. And now, the more manual testing I have to do, the less confidence I actually have that my program is not broken. D4, P5, E5. Q1. Okay, Q1 to A5, capital Q1 to H5, H4, Q1. Okay, queen seems to feel a little bit more confident. Let me run my this one. Pretty good though. Okay, so I got my queen piece refactor in. So we're gonna do get status, get add all this, get status, make sure get commit, and work in progress, add queen piece, refactor, queen logic to be encapsulated by queen piece. Okay. All right, look at what we got here now. This tile select method is a lot less intimidating. In my mind, it makes a lot more sense. I can actually, I'm gonna make it so that this method, this get piece, is going to throw an exception if this value is not here. So this can be throw. I should probably make an exception, but I'm gonna throw a new state. What is it called? Exception. I want like an illegal in Java, so I'm a little more familiar with Java because I've taught AP computer science quite a bit. I want like an illegal state exception. So what I feel like I always have to look up exception. What are the exceptions? Defined by 0, method access not supported. I'm gonna Google it real quick. Just I don't want to waste time. C# illegal state exception. So the game is in a state. Oh, it should be an illegal argument exception. Illegal argument exception. So what's really happening is the symbol is not a valid symbol. The symbol is not a valid piece on this board. All right, so this should only work for the symbols. All right, that's what we're going for. So now in my program here, I can sort of, what is this saying? Converting literable, and then I want to say that this is guaranteed to return a non-null eyepiece, because if it doesn't, it's going to throw an exception. All right, so we can get our eyepiece like this, and then we just do piece.getMoves. So we get our eyepiece, piece.getMoves. Then down here, we know that so please enter a thing, and then it's gonna go to we want to like do this loop again, so I'm gonna do continue. So what's gonna happen is please input the correct thing, and this is gonna continue says go back to the top of the loop and run it again, and then I can get rid of this if altogether, that else part, so this just becomes okay. So we're gonna get the check that the selected tile is valid. If it is, check the logic. All right, so we're gonna say if the piece logic is invalid, display invalid move, and then move on. And then I'm gonna put continue here as well. This is just my personal preference on these things, so I don't go, so I have fewer indents. And then at the end, if I make it to the end, I'm gonna return tile. That means that we're happy with the tile that we've selected. Yeah, let's see if I broke anything. I feel pretty good about that. It feels like I haven't broken anything. Okay, this is really cleaning up nicely. I'm really happy with how this is cleaned up. It's a little bit more object oriented. Let's clean out some of this white space here, just for my sanity. Okay, tile select. I'm so pleased with this. I'm gonna rename this, just for myself, capital T tile, capital S select. That is the C# style guide wants it to be a capital letters. So I've done that just to make myself feel a little bit less crazy. I want to have a method here. It'd be nice. Address list that contains tile. I want a method. I really want to have a thing here that just says string tile equals get tile, and then not have to worry about doing this check here. So I'm gonna write a method here: private static string get tile, and essentially I want to move this logic here. All right, so we're gonna format document. And if they type in back, we're gonna return back. All right, so this is gonna be something that has to happen down here. I'm gonna say if, so I'm gonna do string tile equals get tile. This is what I want. And I say if tile is back, do this thing. So that's what we had before. I think. All right, we're gonna find out. Else, we're gonna say if So ref add has to be down here as well. Get ref add. And then we're gonna say if it doesn't contain this, return get tile. We're gonna ensure that we always have a proper tile in this case. All right, so I could also do like a while loop here, like a do while loop. I'm gonna be a little lazy. I'm gonna do some people will yell at me and say this is bad, but we're gonna do some recursion here. The only time we're getting a Stack Overflow with this type of recursion is if we have a very malicious user who is like typing in the wrong thing over and over and over, in which case I don't care. I don't care. So get tile here, get the tile. So I don't have to have that logic here. I just know that get tile is guaranteed to return back or a valid tile. Let us do this. I know there's a couple backs in my input, so it should hopefully be okay, but we'll do another manual test as well. Let me change my delay. Oh, I love how much shorter my main program is filling here. I don't have all that code in there. All right, so let's try P1, back, it still works. P1, banana. Yeah, P1. A5. Invalid movement. A4. Okay, so I'm happy with that. I'm happy with that. Although previously it probably redisplayed the board. So not exactly what I want. But I think I'm okay with it. Because we do changes. If we wanted to. Is that what it would display before? If we wanted to, I think we could just do this. Is input correct? It's interesting there wasn't a thread delay in there. Thread.sleep delay. I think it just went back up to the top. And had you select a piece again. P1. Banana. Okay. I'm not sure. I'm just gonna have it say input a correct. I don't know if I'm just gonna have it do that. All right, I'm okay with it. The logic of the game continues to function. Tile select feels so nice. Look, it fits on one string. That's the thing I always tell myself. Your method should almost always fit on one screen. Very rare cases. Queen's logic, maybe a rare case, but I'm actually, we're gonna go back. We're gonna refactor each of these chunks to be more testable as well. All right, feeling pretty good about this. I think it's just telling me that ref add is unknown. Index tiles unknown. All right, cool. So making progress. Let me get a commit in here. Get status. What did I change? Let's look at this diff real quick. This is like miscellaneous changes in here to refactoring. So I pulled out various things. My game state, what's different in my game state? Added an exception. All right, so that's the core thing that I did. Added an exception to getting the wrong game state. Refactored tile select to be a little bit more trim, which I'm happy about. And we're saying if this wasn't it, we loop around. Okay, so get add everything, get commit -m refactor, and the refactor was refactor extract or game state dot get moves. Sorry, game state dot get piece throws exception. That's right. Game state dot get piece throws an exception if the piece is invalid. Additionally, abstracted get tile method. Okay. All right, so that's my refactor so far. I'm gonna stop here for now. I might be back later today, I'm not sure. But there's more work to be done, but I've pulled this out into, I've reduced a lot of code repeat. I've removed a ton of if statements here. There was a bunch of if statements here previously. Now is all deferred to this get piece method. And this get piece method has a single if in it. And all of the logic is based on our subclasses that we've created here. All right. I hope you found this helpful. I'll see you next time.